So, good morning to everybody, and I have to give a special thanks to all the organization, with four organizations, especially to Antonella Trombadore, because she gave the opportunity to show to this important audience and this important event the results of the big project and also the Magnitude project, which are very similar. I think that they are twin projects because they have a lot of similar activities, aims, and solutions, especially in the digital opportunities that they give. I am an architect. I work as a researcher at the Institute of Heritage Science of the National Council of Research of Italy. I will give a brief overview of the project because after all the partners of the consortium will explain, will show you the result of each country. They're very interesting as well. So, in the summary, these are the main topics I will briefly talk about, that are the context, the area of the energy efficiency in the built heritage, the challenges of the project, the Italian case study, because the other case study will be shown after, and just an overview and the main results of the project. An overview of the framework. As the EcoSure project, BIP is financed by the European project ENI CBC Med, which is the largest cross-border cooperation initiative implemented under the European Neighbourhood Instrument ENI. The objective of this program is to consolidate, to enforce the relationship between countries that are near the neighborhood relationship. How enhances social and economic development, also through environmental challenges, which is the priorities of the program and the priority also of the B project. The consortium is made up of 8 partners of 7 European countries, from Spain, Istituto Valenciano dell'Edificazione, for Italy the coordinator, Institute of Heritage Sciences and Minucci Associati, and then several institutes. From non-European countries, the Lebanese Center of Energy Conservation in Lebanon, the Center of Cultural Heritage Preservation in Palestine, the Royal Scientific Society in Jordan, which today is not present because they have not the visa on time, and the Egypt-Japan University of Science and Technology. In this way, we could test these emerging technologies in 7 different Mediterranean countries, so we can demonstrate its scalability to the entire building stock of the Med area. Our project tackles different issues. I will just talk about these main 5. The leitmotif is to approach the energy efficiency in historical public buildings heritage with the use of a strong digitalization and the design of support decision tools. Just an idea what it's now going on. The European Union was an early mover on the climate change adaptation and mitigation policies, but still is lacking really coordination actions. So, under the wave of the European Green Deal, maybe you know, but the cultural heritage stakeholders led by Europa Nostra have recently published the European Cultural Heritage Paper, Green Paper, in which heritage is finally framed in these dimensions as a key source and a driver for the fight against climate change. Why BIM? Why the choice of BIM? Heritage Building Information Modeling represents, in my idea, and I'm not alone on this, one of the most interesting lines of research for the digital management of the knowledge, the great huge of knowledge that has been produced during the conservation project of architectural heritage, as well as a building performance simulation that allow the study, the optimization of energy performance in an integrated way. Why? By the way of the creation of a behavior model of a historical manufacture and all of its components that go in from envelope, technical building system, occupant behavior. And like BIM, building performance simulation can be considered as a simulative approach in a different way, and can be assumed in a category of non-destructive analysis because they are particularly interested to support conservation process of historical buildings. Then the interoperability, so between these two environments. Although BIM model already contains a large amount of the data that have been required for simulation interoperability, saving time, cost, reducing the risk of errors, but the data transfer now is still not very efficient, especially in historical buildings. The data transfer takes place mainly throughout two open file formats. One is IFC standards, and the other is Greenville extensible markup language. This diagram represents the workflow of the B project and underlines the centralities of HBIM platform for a series of analysis and simulations that are necessary for develop the design solutions. Then the project provides a powerful support, a financial support, which is the energy performance contracting that are based on energy savings obtained by retrofit of buildings. So in this case, we can involve private funding for the realization of these interventions that cannot be only on the chart, on the paper. We are really involved in trying to find funding this kind of project. So we are going now in the case study, the Italian case study, which is a listed building in the Renaissance Center of Rome, is the headquarters of the Legal Council of State. That means that we have to deal with the lawyers, and this is it was not so easy deal. But only because the occupancy of the building is very, very different, and so it was difficult to analyze the really utilization of the areas of the environment. The first activity, of course, regarded as usual the historical and architectural analysis. This is essential for the knowledge of the building. And it's also a starting point for all the other in-depth analysis of the energy environment conservation state. These are the Then we carry on the geometric survey of the building, creating by integrating different technologies. They will be described by the other Italian partner, Minucci Associated, who worked in the same case study. We use also photogrammetrics that allows the conservation state analysis in deep, including the descriptions of the materials and the decay and the deterioration pattern that you can see here represented in thematic maps. The knowledge of the damage of the constitution elements was fundamental for the design of energy improvement interventions. Then we perform a set of energy and environmental analysis. First of all, the thermographic survey with the aim of getting information of the external and internal walls in which we didn't have any documentation. So it is also support for identify the wall stratigraphy. And we combine also with the consultation of traditional manuals that were very useful. With the combining all this information, we could give not only the composition of the layers, but also the dimension of them. All the thermographic analysis allowed also identify more recent interventions, transformation undergone over the time, as well as conservation problems such as thermal bridges, capillary rise of water, humidity, degradation of the internal layers. And this analysis is made possible to identify also the measurement point of the thermal fluximetrics analysis. And we try to optimize the choice of the point to fix, to make this kind of investigation, with the additional numeric simulation of the sunshine hour of the building during the winter times. At the same time, we carried out also analysis for monitoring and characterized the indoor microclimate. That this kind of investigation provides us useful data for the calibration of the building dynamic simulation model that we carry out after this phase. So the next step was the creation of the energy efficiency HB model, that is like a centralized repository to optimize the management of the large amount of the information that was deriving during the simulation process. Then, with the BIS consortium, we performed a feasibility study in order to find the best solution for interoperability. That means that each partner has chosen different combination depending on the context of the country, on the regulation point of view, and of course on the knowledge and skill of different softwares. These videos describe the environmental and energy simulation process applied to the energy improvement of the building. The calculation model chosen for the Italian case study was the simplified dynamic simulation. This is very useful in case of historical buildings and in the Mediterranean areas, because they allow to take into account the complex behavior of the heritage, especially in the massive behavior, and better address the summer condition in general. The software chosen is Thermolog by Logical Soft, as it is one of the first in Italy to fully integrate the simplified dynamic calculation method. The result of this analysis and simulation led us the definition of a performance-based design workflow that consider the main criteria of compatibility, efficiency, economic and environmental sustainability, because of course the amount and the money are not with limits, and so we have to consider this in order to obtain the most efficient retrofit solution. For all the proposed interior solution, we applied this sequence of evaluation actions that go from the description of the current state of the parts till the estimated cost of the intervention. I just would like to take you to your attention some of these solutions. One of the main is that I've chosen to be shown, that have been evaluated and announced, is the bioclimatic photovoltaic buffer zone that was created in the internal courtyard of the building, that involves also the shading system with a natural ventilation and of course PV panels. So the roof of the battle space is wrapped with photovoltaic panels, semi-transparent photovoltaic panels, allowing the production of renewable energies. The solution was first evaluated from the technical and economic point of view in this simple model. This is the situation ante opera, so you can see it's a completely courtyard, cloister abandoned and not used from the users. The design solution was developed together with Minucci, the Italian partner, verifying its compatibility with the historical value of the building and with the existing structure and constituent material. So the roof recalled the historical tradition vaulted system with 4 laminated wood arches. The structural elements so are more compatible with the historical architectural context. Pardon me?
You're doing also
The other two colleagues. Too late. I go just a little bit faster. So it's recognizable. The intervention is fully removable, does not alter permanently the building, and the idea is to create buffer space to enhance and use these resulting areas. Also, the structural integration was studied in deep, and the design idea was avoid the placement of the structure in the intermediate floor. It was not suitable for supporting the loads, and we anchored the laminated woods in the wall with the sea profiles. I go further. What is important that is its opening. The panels are semi-transparencies and providing power in situ, but assure natural lighting. They are ultraviolet and infrared radiation filter and permanent protection against climate conditions. And the behavior is different during winter and summer because they have these lateral wings that can be open depending of if we are in summertime or in winter time. Just go. So in summertime we will open this part. The buffer space can avoid the overheating during the day and the shielding reduce the solar radiation. These are some facts and figures. But go very, very quickly on the other, Pedra was speaking about windows. Also, we are very conscious that they are very important elements that can be changed at all and can be restored and enduring their performance. So we want to replace the shutter of the windows that have been removed because they were too heavy and so they were also dangerous. But we replace it with light PVC panels. Very quickly, these are different kind of insulation depending on the situation of the envelope. We show these different kind. Insulation of the masonry, insulation of the exodus of external walls that have no decorative elements, depending the insulation of the wood and pitch and roof, and so on. And also ameliorating and we work also on the plants, substitution with the substitution of the existing heat pumps. I will not speak about the other case study, just to have some idea what we are speaking about, so I go very fast and go to the conclusion. Let me say that some of these case studies in the other countries are buildings of very high historical values, and in particular in two countries, it was the first time that the BIM were using for the restoring and the energy efficiency use. So I think it is very important goal of the project. So let me go to the conclusions. The big project in my idea, main results are the establishment of a common framework among all the partners. We set up and harmonized the project workflow depending on local specificities. Furthermore, we have not only reached but even exceeded the performance indicators of the program that the program required in terms of the carbon dioxide avoided and kilowatt of renewable produced. Now we are supporting the public administration, building owners, and managers for realize the renovation project, also with the use of energy performance contracts, helping to write and sign the correct way of agreement with the ESCOs. So that's all.